In today's session, we are going to discuss about dimensional hierarchies as well as adding multiple sources and all. Okay. First of all, let us discuss on this dimensional adding multiple sources. Okay. And after that, we'll be going to discuss multidimensional hierarchies. These are called as dimensional hierarchies. Okay. First of all, let us discuss about this adding multiple sources. Adding multiple sources is nothing but here we have developed some RPD till yesterday. Okay. Now we want to add some more other new tables and we need to enhance our reports, like adding with new columns or some new tables got updated in the data warehouse. As our business keeps improving, some new tables will keep on adding. We need to add that tables into reports and we need to generate reports on them. Then how we are going to handle such scenarios. Okay. In today's session, we are going to discuss more in detail about adding some additional sources to the existing RPD or existing reporting part. Okay. In order to do that, click on this file. Okay. Click on this open online. Here we need to provide password for this. Administrator. AD capital A admin 123 as well as same password here even. Okay. Now this opens whatever the RPD that is deployed into Oracle BI server yesterday. Whatever the RPD that we have deployed into Oracle BI server in our previous session. Okay. Today we are going to import some more additional tables. Okay. We are going to import some more additional tables into our project. Okay. How can we do that? Can you guys say how can we do that? We need to import some more physical tables into our project. Can you guys guess how can we do that? Yes, exactly. In order to do import, yes, we need to import them from any of the connection pools. Okay. In order to import data from connection pools, what we need to do is here. This is the connection pool through which we are importing the supply to tables in that supply to schema. So we'll be using this particular connection pool. Right click on that connection pool, click on import metadata. The moment we click on this import metadata, here it will be like the same step. We are going to uncheck these keys and foreign keys. We are going to import some tables. Click on next. And in here, expand this supply to, and in the supply to, we are going to import suppliers, product type, subtype. We are going to import these following five tables. Okay. Okay. Now these new five tables have been imported over here. Click on finish. Okay. Let's create aliases for these tables, or else you can use these direct physical tables even. It's not a problem. But it's a best practice to create aliases in larger projects. What happens is here the number of dimension tables or fact tables. Sometimes depending upon the product requirements, one table will be used at many places. Okay, in order to avoid confusion and in order to avoid confusion touching the main physical tables, they will be creating aliases in real-time scenarios. Okay, here now I am using these tables directly. Okay, now tables importing part has been completed. After importing tables, what is the next step that we are going to do? The next step that we are going to do is we will be creating joins. Like we need to define the relationship among the existing tables and the newly imported tables. For that, right click on the selected tables, go to physical diagram, select objects and all joins. Here we don't have any joins for the newly imported tables. Okay, now it's our duty to create joins among all these tables. Okay, I'm just adjusting these existing joins tables. Okay, now this table is actually not needed. Sorry, e1 underscore products. I have imported this once again. 2, 3, 4, 5. Sorry, 1. This alias for this product table has been present already over here, so it's not required to use it again. Okay, now I am rearranging all these tables because all these newly imported tables are related to these products only. So okay, so for our convenience, I'm keeping products in this side so that we can easily join to these other tables. Okay, product subtype, product type, price list, date types. Okay, now we need to do our actual job only. Okay, are you guys interested in any one of you are interested in creating these joins? I will provide you access to create these joins.
No, sorry. Your work is appreciated.
Mhm. Okay, let me do that. Okay, I'm going to create a join between these D products and D1 price list. Here, the common column between these two tables is maybe this product key as well as product key over here. Okay. As this is online mode, it will be asking for that checkout. Now this products to product date types, that is date code as well as date code. Here products to product subtype. Okay, subtype code, subtype code, and this subtype to type, item type, type code and type code, and the last join between these D products and suppliers, supplier code, supplier code. Okay, now what we have done is we have just imported some 5 new tables and we created joins among them. Now our schema is like what do we call this schema? Previously it was star schema. Now what do we call this type of schema? This type of schema is called as snowflake schema. Here the dimension is connected to some other dimensions. Okay, but in BMM, I said already, most of the schema should be it should be a replicate of star schema only. Now we are going to look whether how we are going to convert this snowflake schema in this physical layer into just appearance
Actually,
wise like star schema in this BMM layer. Okay, Karen, Hari.
actually,
Yeah,
actually, you join those dimensions and outside here. For those tables, whenever we are joining them, we require keys, right?
yes. For dimensions, after
So,
creating joins, keys will be automatically created in background. That's why, as I have imported all the dimension tables, I have not created keys separately. See what happened. See here. For this price list, as I have joined it to product key has been created automatically in the background.
okay,
For dimensions, keys will be automatically created. But for our convenience sake, it's better to create keys before doing joins. If you do that, that keys symbol will be appearing during that in that joining what do we say dialog box, so that it will be convenient for us to identify joins, identify keys
okay,
for our corresponding joins. But even though if it's not created even after joining, keys will get created for these dimension tables. Okay.
okay,
Now I have imported these 5 physical tables into this physical layer. Now I just want to add these newly added columns into this particular products. Okay. Now what I am going to do is I need a star schema right now. Okay. But here it is like snowflake schema. I am going to route all these newly added columns through this LTS. Okay. As I am going to route all this through LTS, here it will be like only 4 tables only. It will be like 4 tables only, and the outer appearance will be like star only for the system. It will be like star only. Okay. Now let us see how we are going to do that. Now what I am going to do is, as d underscore products and d underscore price list tables both do have a direct join among both these things. Okay. As per our previous join, these products, okay, these products and this price list is directly connected to each other. Okay, as it is directly connected to each other, it has direct join relationship. There is no need of creation of one more logical table source and all. What we can do is we can directly drag and drop this onto this LTS, because as there is a join, it is allowing to drop on that. Okay, now what happened here? The moment I drag and drop this table onto this LTS, this list is already having this price, sorry, this product key as well as supplier code. Okay, as both these things are already present, no new column has been created for that. But this price, see, this price is the new item that is getting generated over here. This new item has been added. Similarly, the same thing happens for date type as well. The moment we place that, date type has been new column, like new logical column, date type has been created. Why? Because this date code is already available over here. Okay, as we have created join among them, and we are giving it a clue that this date code is already present over here, and this is joining to this. We are providing an indication for that both these things are same. So as we are providing an indication for that, like both these things are same, okay, it's not going to generate duplicates over here, and we are giving an identity to it, like we can use this same logical table source. As we are going to drag and drop on this same logical table source, it is treating like both these things are same. If you drag this particular table and if you drop onto the tables or business model, then what's going to happen is it's going to treat this as separate connection kind of thing, and a separate logical table source will be created for this particular table. Okay, let me show that as well. Instead of dragging and dropping on this particular LTS, if we drag onto the table, as this is already present, it's not accepting. But if this is not present, then it's going to create some separate LTS for that. Let me try deleting this thing and try it now. See what happened now. Even now, it's as it is having direct relationship, it's getting routed through this LTS only. But if you want to create some separate LTS even, we can create that. Okay. Now in the coming import, we are going to show that. Okay. Now I have imported these date types. Now I have imported this price as well. Both these things are complete. Okay. See now, let me show this business model diagram. Here what's happening is this subtype is directly connected to products, but this product type is connected after this subtype. Okay, here the direct relationship is not there over here. Okay, you guys can observe clearly that product is connected to subtype, and then this subtype is connected to product type. Okay. The moment if I try to import product type, I think it's not going to accept. Why? Because there is no direct relationship from that LTS. See, it is in blocked mode. Why? Because it is not directly connected to the particular table. Okay. Now what we need to do is, first we need to import this thing. See, now it's accepting subtype as it is directly connected. After importing subtype, the connection pool will have connection to this particular subtype table, and this subtype table is connected to type. Now it's going to allow this. Why? Because a relationship has already been defined in that particular LTS. So that is the reason why it has not allowed previously. I have imported this suppliers table as well. See now, these 5 particular tables, these 5 high tables have been created over here. Okay. Now what I'm going to do is, I'm going to import all these 5 tables into presentation. See, when I click on this business model diagram in this BMM layer, here it's like just star schema only. Okay, is this clear for you guys? Through an LTS, through that particular products LTS, I am going to route all the joins through one single LTS only. As I am having only just single one LTS, it's treating.
Sorry, what is that LTS?
LTS is nothing but a source through which it's going to it's having address of that tables and columns in physical layer. For each and every table, an LTS will be created right initially.
Oh, okay.
LTS is nothing but place where whatever the columns that are present under a particular logical table, whatever the logical columns that are present under a logical table, or that reference table, okay, to which physical table this particular logical table is relating to, that address will be present over here in LTS. See,
Oh,
this is getting connected to ORCL1 database connection, supplier to schema D underscore calendar. That is this thing. Okay.
okay, fine.
Through this LTS, we are routing. Just we are creating that from this LTS only you can connect to these other 5 tables. So it is not treating them the newly imported columns as a separate table and all. Okay. It is just appearing like just star schema only. When we click on this, right click and view this business model diagram and whole diagram. Here it is like star schema only. Even though it is a physically it is like a snowflake schema in physical layer. Here in BMM layer we have converted that to star. Is this fine?
Yeah.
Okay. Now we have imported all these newly imported 5 columns into this presentation layer as well. Okay. As all our operations are complete, now I am going to click on this check-in changes. Consistency check fixed certain. There are no errors. Now our entire development is fine because we didn't get any kind of errors over here. Now let us check whether all these newly imported 5 columns are working perfectly or not. I am trying to open my browser. I am opening this analytics page. Provide username and password over here. That is WebLogic. Admin 123. Sales subject area M. Okay. New analysis. Sales subject area M. Okay. I am going to generate table with this customer's name, year, description, price, date type, subtype, item supplier. Okay. I am clicking on results. See, now everything is working perfectly over here. This is fine. Now we can confirm that whatever the joins that we have provided are working correctly. Okay. This is nothing but adding multiple sources. Whether how can we add newly added tables to our particular project. Okay. And we do have some checkpoints over here, like some protocol checks. Okay. They are like inside one LTS, we can integrate n number of physical tables to convert snowflake schema to star schema. Okay. Inside one LTS, we can integrate n number of physical tables we are going to do this operation just because to convert snowflake schema to star schema. Okay. And the next thing we need to remember over here is if you have direct join, okay, if you have direct join, then we can drag and drop that particular table onto LTS. If you don't have a direct join, then what we need to do is we need to drag and drop that particular physical table onto logical table. Instead of dropping it on LTS, we can drop it on logical table. If you drop it on logical table, what happens is a new LTS will be created for that particular table. That's it. Okay. These are the main protocol checkpoints that we need to remember while importing new tables into our project. Okay. This concept is completed. Is this fine for everyone up to here? Okay. Now quickly I'm going to jump into this dimensional hierarchies now. Okay, dimensional hierarchies are nothing but we do have some three types of dimensional hierarchies in OBI, that is like level based hierarchies, parent child hierarchies, and unbalanced hierarchies. They are like, I'm going to write them over here. Level based hierarchies, which is very important thing. Okay, the next thing is parent child hierarchies. And the third thing, this level based hierarchies is present in both OBI 10G and 11G, that is in previous version of OBI as well as this latest version. Okay, these parent child hierarchies and unbalanced hierarchies are new concepts that are introduced in OBI 11G. In old projects, both these bottom parent child hierarchies and unbalanced hierarchies will not be available. Okay, in today's session, we are in the coming session we are going to discuss on this level based hierarchies in detail. Okay, these parent child hierarchies and unbalanced hierarchies, we are going to discuss that later in later point of time. Okay, this level based hierarchies is very important now, and in every project they need these level based hierarchies. Without this, no project will exist as per my knowledge. Okay, level based hierarchies is nothing but in level based hierarchies we define one to many relationship among columns, that is one to many. The relationship will be like we do have some let us say we have some like products, like or else like type, product type, and we do have some other thing called like product type, product subtype, sorry. Each and every product type will have many subtypes. Okay, let us say like beverages, like product type as beverages. In beverage, under beverages we do have some many subtypes like soft drinks, okay, alcoholic beverages, okay, like milk beverages with milk products, many things. Okay, in the similar way we do have many one to many relationship among different scenarios. Let us say a person holding a single account number, okay, single account number, but that account number he have multiple number of loans. Okay, that will be a subtype under his main account number type, like that. Okay, we do have we do face such scenarios at many places in our real life examples. Okay, let us start working on that, how to create some dimensional hierarchies. Now I am going to create some these dimensional hierarchies on this all the dimensions, like this products, calendar, as well as customers. In order to do that, what we need to do is right click on any dimension table. Okay, click on this new object or create logical dimension. Now we are going to work on this dimension with level based hierarchies. So click on this dimension with level based hierarchies. Sorry. See, this particular object has been created now. This symbol is nothing but dimensional hierarchy. Okay, here by default some particular levels have been created already. Okay, and at the bottom level it will be adding whatever all the columns that are present in our presentation, sorry, in our logical table, all these things will be available over here. Now what we are going to do is, here only this main total level as well as bottom level has been created, but we do have some 4 levels for these products over here. The 4 levels are for this calendar, we are going to define 4 levels. They are like year, quarter, month, and day. Okay, these are the levels that we are going to define over here for calendar. And for products, we are going to define like type, subtype, generic, specific. And for customers, we will be defining some levels like region, district, sales rep, and customer. We are going to work on these 3 scenarios now. For calendar, we will be defining year, quarter, month, and day. Let us rename this bottom level as per our example that we have designed. Our bottom level is day over here. Okay, let's rename this bottom level to day. Okay, on the top of this level, we do have some parent level, that is month. We are going to define parent level as month. On top of month, we do have some level called as quarter. Okay, on top of quarter, we do have some other level that is called as year. Okay, now we have created 4 levels: year, quarter, month, and day. And this is total period. Let's rename this to total period. That is top level. Now we have defined 4 levels. Okay, after defining these levels, the next step we are going to do is we need to import some columns into this particular level so that it can treat that as this level comes under this. This is the parent and this will be the child. Okay, in order to we need to provide guidance to the tool that which one is like acts as a parent and which one acts as a child. Okay, but here if you look at the data that is present over here, the particular quarter column, okay, this particular quarter column is not available over here. Okay, if you check all the columns under over here, quarter column is not at all available. Okay, we already know how to create logical columns. If you require any logical column, we can create logical tables, logical columns manually from existing logical columns. Okay, we are going to create a new logical column called quarters. As it is not available, we are going to create that. Okay, new verb. In order to create this new quarter column, what I am going to do is, here we have something called as month code. Okay, month code is nothing but month number, like 1 for January, 2 for February. Month code is nothing but just month. See, month code is nothing but it's okay. Sorry. See, this is the thing. We are going to use this month in year. Month in year is nothing but it's going to define a number for that particular month, that is 1 to 12 will be available over here. Okay, with this we are going to write some logic over here, like case when statement, like case when these periods is less than 4, then it comes under quarter 1. If it is greater than 3, okay, it is less than 7, or else we can write a case when statement over here, like if it is greater than, if it lies between 1 and 3, it's called as quarter 1, and 3 and 6 it's called as quarter 2, greater than 7 and less than 10, then it is called as quarter 3, and greater than 10, then it is called as quarter 4. Okay, you are going to define 4 quarters over here. In order to do that, just right click on this calendar table, click on this logical column. Okay, the name for this logical column is quarters. Okay, here it is asking for column source. Now we are going to derive this column from other logical columns that are that already exist over here. Okay, just click on this edit expression button, select logical tables, select calendar, and in this calendar button, now we are going to write some statement over here, like case when I'm going to import this month in year. Case when month in year is less than 4, that means it's going to accept up to 3. Okay, is less than 4, then you can, this value will be 1. Okay, when month in year is less than 7. Okay, here we have already defined less than 4, right? The next values will be treated in the logic over here in this case when statements. Okay, if it is less than 7, then it is 2. Again we are going to write one more when. Now we need to provide it's less than 10, I think, or 10, then 3. Okay, all the above 3 conditions are over here, right? Okay, there is no need to write one more when. We can write else 4, and we can write and over here. Okay, now our column formula has been complete. Now this new calculated column quarters has been created over here. Okay, now we have created dimensional hierarchy over here, right? Here in day level we need only date. Okay, so we are going to remove all the entire stuff over here. Or else let them be over here until we import. For month level, what we need is month. Okay, drag and drop month into that month level. In quarter level, what we need is quarter, but quarter is defined over here. Okay, let's import this quarter. Oh shit. Okay, I was unable to drag and drop it over here. See, quarter is present over here now. have placed quarter in this quarter level, and the thing that is left over is year. Okay. Now I have placed each and every individual column into its particular level over here. Okay, I have placed each and every individual column into its particular level. I don't want all this other stuff. As I don't want all these things, I'm going to delete them from here. See, in day level, I have created this YYMMDD, that is nothing but date. For month, I have given month, and for quarter, I have given this quarter. This part is complete. But after that, what we need to do is we need to provide some levels. Like we need to provide some key for each and every level. Why? Because if it is like month, for each and every year, month will be common. How can I say? For 1991 January, the month code will be 01 January only. And for 1992 even, it will be like January will be same for each and every year. Okay, it cannot be identified as an unique key. Okay, so in order to avoid such confusions for the tool, we need to define a key for each and every level. Okay, in order to do that, we can do it in two ways. Right click on it, new object, or you can double click on it. We can define keys over here. D1 calendar, it will be used for display, and it is already defined as a key over here. And for the same thing here we don't have any keys over here, right? So if we right click on that particular column, we can define that particular column itself as a key using this right click new logical level key. Then this particular key will be created automatically. See, or else we can do this manually from clicking on this add button or writing something over here. Okay, and for quarter, this quarter will be the key. And for year, here year will be key. But for month, we have provided month over here, but actually it needs month code. Why I am providing that, I am going to show you now. Month is nothing but, see, it is just like January, February, March and all. But if you provide this data to this level, what happens is it will get messed up. Why? Because under every quarter, okay, that quarter may be a quarter from Q1 of 1991 or Q1 of 1992. We will be having two things over here. Okay, in order to avoid such confusions, and instead of giving this month as key, we are going to give month code. Okay, month code will be something like unique. Month code is nothing but for each and every year, a separate month code will get generated, 1998-02-06 like that. Okay, so I am going to import month code over here even. Okay, I'm displaying this month code as key even. Now what I need to do over here is, here this month code is unique key, but I don't want to display this month code because it won't be like it won't be nice for the customer to see like month code like in that confusing format. Everyone is comfortable with names of month like January, February and March. Okay, now what I'm going to do over here is I'm unchecking this. Here it acts as a key internally, but it won't get displayed. Here it acts as a key and it will be displayed. Okay, it is used for display. After providing, after defining keys for each and every level in that particular dimensional hierarchy, the next step we need to do is we need to double click on whatever the particular logical table for which we have created this dimension. Okay, you need to double click on that. Or properties. Oh, sorry, I need to click on this LTS. Here in this content tab, we need to define level. Okay, we need to provide in detail for that. We need to provide in detail, like we have defined some logical dimensional hierarchies over here. For this logical dimensional hierarchies, what is the lowest level? Okay, we need to provide lowest level for that, so that it can treat it as the very lowest level. Here among this, we have defined all these 4 levels here, right? We have defined this day, month, quarter, year, and period. Okay, in this we need to give it a guidance, like up to which level we have data in our particular logical table. Okay, even though we do have some levels in this dimensional hierarchy, if data is not available, it can't show, right? So we need to provide it a guidance, like up to which level data is available. Okay, we need to provide this day. Okay, by this all steps are complete here now. Now I'm going to check in changes. See, it's displaying some warnings over here. Logical dimension table customer details have a source LTS customers that does not join to any fact source. Okay. What's error is getting displayed over here is in facts also we need to provide mapping to it. Even though here we can provide it as we should not define anything over here. Nothing. See, automatically something got displayed in source event, but while displaying while checking a single dimensional hierarchy, we should not do that. Now click on checking changes and let us check whether our dimensional hierarchy is working correctly or not. We can even import this dimensional hierarchy over here to this presentation tables. Click on check in. Now some error is getting displayed over here. Sorry, I have directly imported that dimensional hierarchy onto the table directly, right? That is the reason why we are getting this error. Instead of that, let me import that separately under subject area itself, but it's not accepting. Okay, let it be. Presentation level subject area cells hierarchy has no display columns. Okay, it is displaying error like it's not having any display column, but we can ignore such warnings. Now let us check how this is getting replicated in our front end. Go to criteria, go on reload server metadata. Data has not been refreshed even. this hierarchy is not appearing over here. I don't know why that hierarchy is not getting replicated over here. Now I have done this check-in. See, now it is getting replicated over here. Now I am going to create a report like with year. Description of the product and its sales. I'm clicking on results. Here the color of year has changed here, right? See, the color of year has changed over here, but this color of the bottom thing color is not getting changed. That was some browser issue. Okay, but if I change its data type to some other data type, then it will be treating it as a dimensional hierarchy. Now let me show how can I do that. I'm generating some new column for year over here. Okay, instead of disturbing the original things, new logical column. Year underscore dim. Okay, and in this column source place, I'm going to derive from existing columns. I'm using some type conversion functions. Or else I will be using this. Okay, varchar of no, it's not accepting. We have some type conversion function, but if case operators between null expression. Okay, I'm trying with this cast function. It's not that much useful. Okay, I'm converting this particular thing to character of. Let me check this thing whether it will work or not. Or else let me try it over here. Let me treat this here. Check out. Double. You do have some function over here. Do you have any idea of functions to convert like double to character, Harish?
Right?
Hmm?
Converting data types, right?
Yes.
Double to character casting, type casting.
Uh, where is that cast function over here? Here,
Okay.
it's over here.
Where?
I
Cast.
got it. Numeric expression, cast, possible tables, calendar. Here, yes. Varchar. I think it works now. Cast numeric expression. Yes. Varchar. I think everything is correct over here, right? What is error that is generating over here? If you treat that particular number as an expression, then it's not going to throw up an error. Let us check for any other alternatives here. Or else let us check with this from month or quarter. Okay, I'm going to add quarter over here even. Sorry, I have not imported that quarter column into presentation tables. are getting some error over here. You can click on close. I'm going to delete this particular thing. Click on this check-in changes. Close. Reload server metadata. Time. And from here, I'm going to import this quarter. See, for quarter, we are getting a hyperlink over here. But in order to get it is treating this particular thing as day over here. It's not. I'm treating this as just a number. Let us see how. Even though it's not getting highlighted, see what I have generated over here is okay. Let me generate a new report. Delete this old report. Okay, from quarter it is working. From year there is a problem with the data type over there. Okay, quarter. I'm generating report with some dollars. Okay, quarterly dollars. If I generate report now, see in first quarter it is like this amount and second quarter it is like this amount and all. The moment I click on this one, it will drill down to the months in that first quarter. Okay, the moment I click on this February, it is going to drill down again to 1998 okay, 0202. See, this is what drill down analysis is. Okay, but for year we need to change that data type. I will check that and I'll get back to you tomorrow. Okay, this is how we are going to create drill down analysis in regular basis. This type of analysis will be useful everywhere. Why? Because it is like product types, subtypes. If you keep on drilling down, it will be expanding like a tree over there. Okay, if you keep on drilling down, it will keep expanding like a key. Okay, but that particular year thing, we need to change the data type. We need to use some type conversion function over here. I just forgot that. Okay, I'll check that and I'll get back to you tomorrow with that. Okay, let us stop here for the day. Do you guys have any doubts till now where we have covered this dimensional hierarchies part? We need to practice that well because it's something like critical. If we get used to that, it will be like very easy. Okay, okay, bye guys.
Bye.